Greetings to everyone. Hope you all are hale and hearty. And I'm Jaswita Pradeshni God, an undergraduate from MBM Engineering College, Jodhpur. And in this module, we'll be going to cover and discuss the solutions to sample paper number 5, question number 1 to question number 5. And this targets class 9. So without any further ado, let's get started. So the first question of the module says, which form of energy will a body possess when it's placed at the top of a hill? So, the answer to this question is very fundamental to understand. It would be the potential energy that would be stored in a body which is kept at a height, or is mentioned in this question, at a hill, at the top of the hill. It would be possessing the potential energy. Now, any object that can store energy as a result of its position. For example, the heavy ball of demolition machine is storing energy when it's held in an elevated position. The stored energy of the position is referred to as potential energy. Similarly, a drawn bow is able to store energy as a result of its position. When assuming its usual position when not drawn, there is no stored energy in the bow. Yet, when its position is altered from its usual equilibrium position, the bow is able to store energy by virtue of its motion. This stored energy of position is referred to as potential energy. The potential energy is the stored energy of the position possessed by the object. So in this case, this is going to be our hill that we're talking about. And right from here, when we are on the ground and we start climbing the hill. So when you're climbing the hill, we are taking the energy and we are converting all of this energy of motion into potential energy here, which is going to be the maximum point of potential energy right here with zero kinetic energy as you reach the top of the hill. And when you start coming down again, you are going to convert this potential energy wholly into another form of energy, which is nothing but kinetic energy. So by the time you reach the bottom of the ground here, all of this potential energy right here is going to get converted into kinetic energy right here. So this was the fundamental of the question. Now let's move on to the next question, which says, in which layer of the atmosphere ozone is located? So stratosphere is the layer which contains the ozone. The stratosphere is a stable layer of atmosphere extending from the troposphere upward to a height of about 50 kilometers. The stratosphere is highly stable because the air temperature increases with the height up to the stratosphere, which is the height of the temperature inversion. The increased temperature in this layer is due mainly to UV absorption by various chemical species, including ozone and molecular oxygen, which is present in the stratosphere. Maximum heating takes place in the upper part of the stratosphere. Because of the stable air, pollutant mixing is suppressed within its layer. Thus, natural and synthetic, that is, natural makes it the oxides of nitrogen, sulfur, and synthetics like chlorofluorocarbons that are emitted from refrigerants and air conditioners. Chemicals that reach the stratosphere from the troposphere tend to diffuse upwards very slowly within the stratosphere. Ozone is formed naturally and photochemically within the stratosphere and is considered a pollutant in the troposphere. But in the stratosphere, it is essential to life on Earth because it absorbs the biologically harmful UV radiations. So basically, what these pollutants like nitrogen oxide, sulfur oxides, and synthetics of chlorofluorocarbon do is that they kind of diffuse into the ozone. And just for a simple example, if I talk about the CFC, you can see CFCs tend to react with this ozone in the layer of stratosphere, wherein it breaks this ozone molecule into free oxygen and a nascent oxygen molecule. This is how the ozone breaks, and this nascent oxygen molecule is then going to react with the chlorine molecules and form substrates and compounds which cannot be reverted back to the origin where which is originally the ozone, right? So this chlorine was breaking down this oxygen to its byproducts of oxygen gas plus nascent oxygen, and this process cannot be reverted, that it may be it does not move in the backward direction, right? You cannot make ozone from oxygen and nascent oxygen. So this is how this ozone which is present in the stratosphere is depleted by CFCs, and similar mechanism also takes place when it comes to talking about nitrogen and sulfur as well. So when you convert the oxygen ozone from its natural state to derivatives of oxygen, it doesn't revert back to the original state of ozone, and hence you have your ozone depletion also happening, which is then causing a lot of other harmful effects on the environment, and that we'll discuss in the next module. Till then, now we move on to the next question, which says, if Z is equal to 3, what would be the valency of element? And write the name of the element. So the valency of this element is -1, and the name of the element is lithium. Right. So basically, how did we know that it was lithium was, if you look at the periodic table, you can see that there is first element is hydrogen, then comes the helium, then comes right here is your lithium, and then is your beryllium, and then so on with these going to be your transition metals between your helium and your hydrogen are your transition metals that are Tm, and then you have your boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. So this is how, in the increasing order of their atomic numbers, these elements have been placed in the periodic table. So lithium comes here, and the atomic number of lithium is 3. Now, in order to find the valency of lithium, we're going to break these 3 number of protons as well as number of electrons, because lithium molecule is uncharged in this state, to find its electronic configuration, because that is going to give us exact information of the valency of lithium. So this 3 is then going to broken up to 2 comma 1, and we know the fundamentals because this is going to be the K shell and this is going to be the L shell. Then if there would have been more electrons, then would have been an M shell here as well, but M shell here is not here right now. So we just have K shell and L shell, right? So the configuration becomes 2 comma 1. Now, as I've already told you a couple of times before as well, that when you follow the octet rule which says that any element, if possessing a maximum number of 8 electrons in the valence shell, achieves the configuration of a noble gas, which is supposed to be the most stable configuration and the most unreactive configuration. So stability is all what any element requires, and that's why if we try to apply octet rule here as well, um, either you can have the maximum of 8 electrons in the valence shell, or you can have, if you don't have these 8 electrons, or you just have 2 in the first shell, even if your first shell is completely filled, then this is also a case of stability. This will also provide the stability as just as in this case of octet. So this is the case that we're going to talk about, because 8 electrons cannot be here, we don't have that much of electrons, right? And accepting 7 electrons is also not very possible, because it's thermodynamically not stable for an atom to accept those 7 electrons from somewhere. It will make the atom unstable. So what do? You remove this 1 electron. So if you remove this 1 electron, you will easily have just a 2 configuration wherein your K shell is completely filled, and again this is the state of stability. And this can be the case, this is how lithium can easily exist, because this is stable again. So when you're going to lose this 1 electron, so what is valency? Valency was the combining capacity of atoms or molecules with a particular number of atoms of other elements. So if I lose this one electron from here, I will easily have a stable configuration, a stable noble gas configuration of nothing but helium that we already discussed. Like it was hydrogen and then it was helium, which was right here, noble gas, and it had two protons that we have already seen in the, we can easily observe this from the periodic table as well. So now what do we do is, when I write lithium, when I talk about lithium, lithium has one electron which it can lose and gain stability. So if I put here that it has one extra electron, lithium, this is a lithium ion, it has one extra electron which if it loses this one electron, it can gain stability. This is how it makes it to be a valency of 1 and a valency of plus 1. Why? Because it has an extra electron which it needs to lose to gain stability. So this is how you find the valency of any element which is given to you. This is the fundamental. So if you follow the procedure, which says that you first have to find the electronic configuration according to the number of protons and the number of electrons depending upon the charge state, and then you go for to check the stability either by putting the completely filled shell property or the octet rule, and then finally come to the conclusion of valency. And yes, the name lithium can be understood when you refer to the periodic table. The elements have been arranged there in the increasing order of their atomic numbers. So yes, lithium is the element with the atomic number of 3 and a valency of plus 1. Yes, so let's move on to the next question, which says calculate the mass of one molecule of nitrogen gas. So nitrogen is basically an atomic number of 7. It is symbolized by this capital letter N and has electronic configuration of helium with 2s2, 2p3, and the atomic weight of nitrogen comes out to be 14.007. Now, the mass of 1 mole of nitrogen gas is 28 grams, and hence, 1 mole is equal to 6.022 into 10 to the power 23 molecules of nitrogen gas, which is the Avogadro's number. Here, right here, this is your Avogadro's number. So 1 mole is nothing but 6.022 into 10 to the power 23 molecules of nitrogen gas. And hence, the mass of this much amount, that is Avogadro's number amount of molecules of nitrogen per gas, comes out to be 28 grams. So mass of one molecule would be this 28 divided by the number of molecules, that is 6.022 into 10 to the power 2 minus 10 to the power 23 grams. And this comes out to be 4.6 into 10 to the power 23 grams. So this is going to be our answer, simply just dividing the given mass of 1 mole of nitrogen gas by the number of molecules that are present in 1 mole of gas. It can give us the mass of 1 molecule of the same gas. Yes, now let's move on to the next question, which says complete the following chart. And this is a chart of vertebrates, the further classification of vertebrates to spices, amphibians, and then we had to fill the A and C part, and then we have mammalias right here, and then pisces are all fishes, amphibians are all that live on land, and then we have to fill this blank right here. And then you have A, which have three chambered heart. This is the characteristic of the species that are going to be present here. And then you have pneumatic bones, again to the species characteristics which are going to be present here. And then you have mammalia, which have dash to feed their young ones. So yes, we can easily guess that amphibians are both which live on land as well as water, and mammalias have mammary glands to feed the young ones. So these two are pretty clear to us. Now, what are the species? There are the three chambered heart species and the ones which have pneumatic bones. Then the three species with the three chambered heart were the reptilias, and the ones with the pneumatic bones are apes. Pneumatic bones are basically hollow bones, and that's what makes the apes, that is the birds, fly, because their bones are hollow, and this makes them pretty light in their weight. And yes, it helps them to fly. And three-chambered heart is the characteristics of reptilia, which is which examples of which have been put on the screen right in front of you. You have lizards, you have chameleons, you have tortoises, and aves are, yes, definitely all birds. Mammals are those which have mammary glands to feed their young ones, and they directly give birth to the young ones. They don't like they don't lay eggs. And yes, amphibians live both on land as well as on water. So, with this, we come to the end of the module. I hope I was able to deliver the concepts to you, and I hope that you understood it as well. And for now, I'm going to take your leave. We'll meet in the next module. Thank you for being a patient audience. Till then, keep learning, keep growing. Thank you.